Okay, so this session here is mainly just to walk you through quickly about the basics for lab number 2. And there's certain points that's already written down in the PDF, but I would like to do some visual illustration together with you. Just make sure you really understand the big picture for lab number 2. It's actually quite a different learning experience than lab number 1. I think for lab number 1, the main challenge would be to use the new syntax for IFO and then to implement some complex algorithm like a rotate and also split, right? That's what you experience for lab number 1. For lab number 2, we're assuming that you already grasp, the basic syntax for the new language. So now we want you to pay more attention to architecture and also specification of your routine, especially the post condition. That's something I also saw. If you have some question there, you can also put on the chat. I will, once I go over the items on my agenda, hopefully it will take no more than 30 or 40 minutes, and then I can dedicate the rest of the time to your questions, okay? Any time. All right. Okay, so let me just go over the PDF very quickly. I may not, I'm not gonna repeat every detail over there. I just want to tell you which part you should really pay more attention to in case you haven't got a chance to read it closely. So for lab number 2, let me just mention, so there are different sections over here. Let's just go over section by section. So just quickly. Learning outcomes, I think what's really going to be interesting for this particular lab will be the iterator pattern, which is more like a second stage of the lab, and also specifying contracts, especially post-condition, using model. Okay, I think one of the questions on the chat is about how you can use the model. I'll give you some example in a moment. Okay, I'll do that. And also to draw professional architectural diagram using Draw.io tool. For those of you who already started the lecture series for week 4, the first part is really about how you can draw design diagrams. So you will learn more details in the lecture, okay? All right, so background readings, really, we're assuming that you already completed lab 0 for sure, so you have a basic grasp of the language. So now, section over 3 here, I really believe this is only optional. So if you believe you already grasped all the ideas about the iterator pattern from the lecture series number 4, the last part is really about the iterator pattern. That one there, I already gave you some example code. I believe that one should be enough for you to complete your lab number 2. But if you really just need some a little bit more in-depth walkthrough of the programming details and getting a little bit more hands-on experience, you can definitely choose any of the tutorial video over here, okay, if you need it, okay. All right, and then section number 4, this is really, really important because for this lab here, you have to use hash table, and also you have to know how to use tuples. Tuples is a little bit like a pairs. If you program in Python, for example, previously, it's like the pair data type that you have. So in IFO, it's simply just called tuples. So if you simply just go to, I'll show you where you can find them. You can just go to your starter projects and go under tests. Go under starter tests over here, right? If you look at the very first 2 tests over here under syntax demo, if you go there, so the first 2 test cases are really about how you can use hash table and also how you can use the relational model and also tuples. So these 2 tests should really give you enough information just to get started. Okay, so I think a partial answer to the question on the chat would be also you can look at this test, but I'll do some visualization together with you as well. Okay, so these 2 tests, you should really read them and also try them out in your lab. Okay. Okay, and then section 5, I think section 5 has been handled already. So let me just emphasize again, although I already made it clear in my announcement. So we have started grading your lab number 1, but even though the process will be automated, but there are some special cases of the submission that we have to look into. So I would say bear with us. I will try my best to really return your grade back to you as soon as I can. And after you have received your grade, it's not the end. It's not fixed in the stone. You can still talk to me or talk to the TA. So I would say for now, don't panic. Just do lab 2. I think that's the best you can do, and just wait for my result. I'll try to return the result of lab 1 to you. Hopefully sometime next week. I'll try. Okay. Okay, so now section 6 will be very important for you to really read in details. So that one really talk about, for example, when we talk about database, and in this case, we're using 2 generic parameters as opposed to just 1, as you learned from your week 3 lecture series, right? I'll let you read the details. And then we also talk about this particular design principle programmed from the interface, but not from the implementation, right? So you will also practice that in this lab. Okay, so this is actually a visualization of the linear database. So in this particular lab, we actually got many classes in the context, right? Even though we give you all the class definitions already, but it would be a nice warm-up for lab number 3 after the reading week. So after the reading week, starting from lab number 3 and also the projects, you will be given complete freedom about what classes you want to create for your design, and also what should be their names, and what should be the routines, and what should there be their signature, and etc. So I think for lab number 2, take it as an opportunity to really understand what's really the relationship and the architecture for the whole lab. That's something you have to summarize in your design diagram anyway. All right. Okay, so the keys array and also the values hash table is just one part of it, the linear database. Okay, I'll get to the classes in just one moment. Okay, and then design decision. In this particular lab, we made the design decision for you already, right? Just to make everybody the same. In your lecture numbers series number 3, when we try to create an abstraction function for the stack, that in that case is simply just a sequence. So now in your lecture series number 4, we talk about how you can create an abstraction function for the birthday book example, which you're very familiar with from lab 0. In that case, we use a function. And now in this lab, we practice another one. So we use relation. So one very quick quiz question you want to think to yourself, right? Because for your lecture series number 4, you are given some self-guided review on the mathematical part, from 1090. So what's really the difference between a relation and also a function? Okay, think about the question there. And then for this particular lab, we are using a relation as the abstraction function for the database, right? And then when you read it through, you have to understand particularly this point over here. So whenever you want to inquire about what's the corresponding value of a key, you're really doing a relational image operation, and then there will be some technical details you have to pay attention to, right? It's already summarized in the written notes. If you got trouble, you can maybe drop by my office hour on Monday or next week. Or you can just ask me today if you got questions. Okay, so this is a design architecture, the most important one. So in the lab 2 instructions, I try to summarize just a simplified version just to get an idea. That's something I would like to demonstrate to you in detail. So I want to make sure everybody's okay. Otherwise, you really lose the valuable learning opportunity for lab 2. I think that's something I don't want to leave you behind. Okay? I'll do that in just a moment. Okay, and then starting from bullet point number 1 all the way to bullet point number 3 over here, right? All the way to here, right? For the rest of the 6.3. Once I make my visualization in front of you, so if that makes sense to you, I would still encourage you to finish reading this. That's actually quite an important summary of what you're supposed to know for lab number 2, okay? Okay, finally, for 6.4, it's about implementing the iterator design pattern. Okay, so the iterator design pattern, there will be 2 classes you have to implement. So one will be the tree iteration cursor, and the other one is a linear iteration cursor. And then you want to pay attention to these 2 bullet points about in what order should your iteration cursor return, right? So these 2 also summarize the important aspects for you to know. All right, so that's about basically the problem we're going to solve. So for now, I'm just going to focus on this particular diagram over here, and then I'm just going to tell you how you can understand this architecture here, and I'll give you also example, like how you can search for example in the starter code, okay? Okay, so now let me switch to my iPad over here. So I put the 3 classes over here, right? I'll enlarge that in just a moment, okay? Let me just bring your attention to the starter code for the moment, okay? If you look at under the database class over here, okay, you can see the blue circle over here is with a little bit like a red shape around the top left corner. So that means the database class is actually deferred, okay? So hopefully for those of you who already started for lecture series number 4, you will know what defer really means. A class being deferred simply means it's partially implemented and you cannot use it as a dynamic type. Pretty much like an abstract class in Java, right? So this idea is not unique. So you know the idea already, just different keyword. So we got a deferred class called database over here. And then we explained about the generic parameter in the Q&A session on Tuesday, I think. So for that part, I'm gonna leave you alone, okay? So, and then so if you look at the features over here, look at the sections over here. You can see we got one section here called Abstraction Function. And notice that the abstraction function at the database level is simply just defer. So that means we got at least one routine in the database class that's deferred. So that's why the whole class should be deferred. Okay. So that's one section here alone just for abstraction function. So that means you can expect anything that's deferred in the database level, they will be effective. They will be implemented in both of the subclasses, linear DB and also tree DB. We'll get to there in just a moment. The second section you want to take a look at will be, it's called a defer routines. You can see defer routine, that's the second section. So we got count, we got hash key, we got search, we got insert, we got delete. Every one of them is simply just deferred, okay? Which means we don't need to implement them at this level here. We will delegate, we'll defer their implementations to tree DB and also linear DB, right? However, for each one of them, what you must do is about their contracts. Because remember the single choice principle that we talked about in week number 3, right? Single choice principle simply means for contract, for example, you want to put that in the minimum place possible rather than repeating them over, all the subclasses. So the idea would be we only specify the post condition in the parent class, in this case database level. They will be inherited, the same copy will be inherited to both the linear DB and also tree DB, so the same copy. So we are not repeating anything. So this is single place. Later on, if there's any change that would be needed for the contracts, we only go to the post condition on the database level. Okay, so that'll be single choice principle. Okay, so now that's about the deferred routines over here, and then about the basic. So you can think about basic, intermediate, and advanced, right? You can see, interestingly, all these features are effective, right? You can see the do over here rather than deferred. So that means all these routines under basic, under intermediate, and under advanced, they must be implemented right at the database level, okay? However, you might be wondering, in this database level, we haven't declared any attributes, have we? If you look at the feature section over here, you can see we only got abstraction function, we got deferred routines, we got basic, we got intermediate, we got advanced. On the other hand, let me just give you one example. If you look at, let's say, tree DB over here, right? You can see tree DB is a class which is not deferred, right? It's just concrete, it's effective. The tree DB inherits from database over here, okay? So now you can see that what features do we have in the tree DB? I'll just give you one example here. We have restricted attributes. For information hiding, only these two classes or their descendants can get access to whatever feature that's inside this particular feature section, okay? So now one of them is simply just BST of type balanced BST. And now this class is exactly what you implemented back in lab 1. So that's where we can build a connection. But for this lab, you don't really have to worry about the correct implementation for your tree classes. Either you can use our solution classes, that's okay, that's definitely acceptable, or you can simply use the grading tests that we gave to you and fix your implementation. That can also work either way, okay? So now, let me just give you a very quick heads up message over here. This database class is the parent class. This tree DB class is the child class. Apparently, we cannot get access to the BST in the database level. Agree? We just cannot. You can never refer to the child class attributes in the parent class. You can only do maybe the other way around, but not from the parents to the child. Right? That's what we know before. Okay, I'll turn to the diagram in just a moment. I just want to bring the important points to you. All right, and then so now the idea would be for basic, intermediate, and also advanced in the database class. Let me close this. In all these sections over here, how are you supposed to implement them? Okay, so the idea would be you want to think about all the deferred routines over here: count, hash key, search, insert, and delete. So these are like the basic building blocks. Like when we talk about modularity, right? We talk about Legos. You can think about each of the deferred routines like an individual Lego piece, and then somehow all the basic, intermediate, and advanced, they can be somehow composed of the basic building blocks from the deferred routines over here. That's in principle. Okay, that's something you gotta work out exactly how. Okay, but okay, that's about a very quick overview of the sections for the 3 classes. Okay, so now let me go back to the diagram here. I want to speak about something about dynamic binding together with you. Okay, okay, let me have a very quick walkthrough again. Okay, so now is a simplified view. So just a quick summary. In a class of database, it's simply deferred. Okay, let me just use this. There's a deferred class and then simply database, right? And then we simply got model over here, which is deferred. Okay, and then we got insert, which is also deferred. So this is deferred routine section. Okay, and then other sections are basic, intermediate, and also advanced. So these are simply just effective. For example, one of them is called override. So that's a basic one. You can see it's effective because you got to do over here rather than defer, right? Okay, so that's about the database structure. Okay, so now what about the individual child classes? Let's take a look at one by one. Let's say in the case of the first child class, you can see we got a class called TreeDB. This class is not deferred, meaning that every routine in this particular class must be implemented, otherwise it would have been deferred. So it inherits from database, and then you can see this is really important. You can see we got BST, balanced BST. On the other hand, we got another class over here. You can see class linear database. So that one is also effective. And that one there has the keys and also values. You can think about the green ones are really the implementation for the child. Implementation. And also implementation over here. And let me just say it again. In order for me to actually implement this particular override, for example, in order for me to implement this, can I refer to BST? No, I cannot. Can I refer to the keys or values? I definitely cannot. The direction is simply just wrong. You cannot do that either in Java, so just the same in iPhone. Okay, that's the first thing I want to mention. Okay, and now let me just go a little bit further. And then you can see in the subclasses over here, you can see the model over here is actually now effective, right? And the model over here is effective. So what do we expect to see? What we expect to see is, in order for you to implement this particular abstraction function and this abstraction function, and this might partially answer the question on the chat, okay? So you're supposed to, for this particular model query, you want to really create the result relation based on the BST. So the BST should be mentioned over here. On the other hand, for this model over here, the same query, but it's in a different context, which means depending on what the dynamic type is, we're going to call different version of the model. So in this case, this particular model is going to use the keys and values over here, right? Okay. Hopefully, so far makes sense. And then we also got insert over here, and also we got insert over here. So that means that insert over here is also going to refer to the BST over here, and also the insert over here is also going to refer to the keys and values, right? You can think about this particular section over here. Okay, let me just be consistent with the color. So this part over here, feature here, and the feature here. For example, insert and insert. That's really referring to what you have to implement from this particular section here, from the database. Okay, all right. So that's about it. And then let me talk about some how you can use it to really understand the architecture. Okay, and then you can ask me questions once I'm done. Okay, so let's say this. Let's start with something simple. Okay, so now let me just go back to this so you can see all the three classes, right? Let me start with some client code. Let's say in the tester class, if I say creates, oh, actually, let me declare something first to begin with. If I simply say DB over here, and to really satisfy the programming from the interface, but not from the implementation, we should really choose this type over here to be as general as possible. Out of 1, 2, and 3, these three classes, which one is the most general one? Of course, it should be the deferred class database over here, right? That's the one we should really choose, okay? So what I would do is I'm going to declare this type over here to be database. Okay, so this is like an interface type. And then, of course, we should really give some instantiation over here, right? We should give one instantiation for the K and one instantiation for the V, right? So for simplicity, I will simply say the K will just be string. And for the V, it will just be integer, okay? Just whatever type you would like to instantiate it to be, okay? So now, let's try with instantiating this particular DB and see what options do we have, we actually have. I can have, for example, if I say creates, over here, right? Dynamic type, it will be in the curly brackets. What about I just do this? If I simply say create db make. Guys, I need your input. Do you think by writing this, is it going to compile? Anyone? Yes? No? I heard no from Parith. So why not? You want to speak up to tell us why?
Because there is no make method in DB.
Actually, you know what? There could be a make method actually in the database. Let's say there's a make method. If there was a make method, do you think this might work?
I'm not sure about that case.
You're not sure. Okay. So, okay, I tell you what you're doing over here. Okay, I'm not sure if this will help. So what we're doing here is nothing new over here, right? If you try to recall a little bit back in your previous OOP course, I just try to see if this can help you. If you do it in Java, right? If you say abstract class, and then if you simply say database over here, right? And then, of course, you got whatever stuff you need. Okay, so this is one class over here. And then, let's say we got just one child class over here, let's say, like that. So it's an inheritance relation that we're talking about. And then over here, you can have class. Let's call that maybe tree DB. Okay, and then, of course, this class is simply not abstract. And then you can actually do something over here, right? So the same question over here. If I declare to say database, sorry, misspelled, DB equals new, and then database. So now, would this be okay? Parith, do you think that will be okay?
No.
Not be okay,
yeah,
right?
Be
because,
okay.
yeah,
this
so
will not be okay.
Would that be okay? Very good, thank you. So you can see this is not okay because database is simply just abstract. So this will not be allowed. The idea would be at the runtime, if you were able to instantiate this, there would be some methods that are unimplemented. So you wouldn't be able to execute it. So that's why it's not even allowed at the compile time. It's exactly the same situation we're dealing with right now. Because you know that database over here is simply just deferred. So that means there's at least one routine that is actually deferred. Specifically, all the features under deferred routine section over here, for example, insert, is simply just deferred. So that means we cannot use the database directly as the dynamic type, right? The same idea as before, okay? And remember what we learned from lab number 0. When you wrote this, it's as if you said create over here, and then I would say database, the same type as the static type over here, and then db.make. Apparently, this is not allowed, right? So both of them will not compile. Okay, the same principle as before. Okay, nothing new. Okay, so now that's something you're not allowed to do. But now let's talk about what you are allowed to do. You can choose any, basically any subclasses of database that's actually effective. And now we got two choices. You can either choose this, or you can choose this, right? They're both effective, right? Let's just choose one of them. And then I'll ask you some question to help you understand, okay? Let's say we try that, and then I'll simply say create, and then I'm gonna pass a dynamic type over here. Let me say linear DB, right? Just for example. Linear DB, of course, you're gonna pass the corresponding arguments over here. I'll leave that to you, okay? And then you will, over here, you'll say db.make. Okay, the make is actually available in both classes. I'm just not showing in the diagram over here. So this, as far as compilation concerned, this will be okay, all right? So now here is my question for you, okay? So now this is okay. So now let me talk about several usages. Number one, if I say db over here, dot insert. Okay, insert according to what is going to be key and the value, right? Let's say it's going to be a string and integer. Why don't I say Alan over here, and then let's say 23. Okay, guys, let's consider this particular one here. So you can see so far what we have achieved was this. Database is the declared static type for DB. On the other hand, linear DB over here is the dynamic type for DB, right? So now the question is, when we are calling this particular insert routine over here, which version of the insert are we calling? That's the question. Before you answer the question there, how many versions of insert do we have? How many versions? You might say this wouldn't be counted as one version because you can see there is no implementation over here. It's simply just deferred, so that wouldn't be counted. So we got basically, let me write it down. For the insert, you definitely got over here, this is insert version 1, and this is insert version 2. Version 1 is defined in terms of the BST. Version 2 is defined in terms of the keys and values, right? Because they are in the context of different classes, right? So now a question for you. For number 1, which version of the insert are we calling? Which version? Version 1 or version 2? Anyone can answer me in the chat. Just tell me if that should be version 1, version 2. Thank you. Yes, exactly. Very good. Yeah. So you can see as long as you can follow through the dynamic path of your execution, you can see, right? Good. So that one there is going to call version 2. Okay, I'll just make a note over here, version 2. Okay, that's a good start. Let me just talk about number 2 here. This is actually a little bit trickier. Okay. Oh, let me just say one more thing. And then when you actually call version 2, I agree with you. But now you want to know about. Remember, we talk about the timing of checking contracts, especially post condition. We say that you check the post condition after the implementation has been executed, right? So now, post condition. We know that we're going to check the post condition of the insert, but where? Where is the post condition defined for the insert? Is it in this particular insert over here? Is it? Not quite. Let me show you right away. In the database, Asma, that's right. But let me just confirm with everybody. So let me just go back to the insert. Okay, so hopefully everybody can see the architecture already, right? So I just want to go over this with you. So if you go to, for example, linear DB, okay? So if you go to insert, for example, if you go to insert, you can see that insert over here, there is a comment over here saying implicitly the post condition from database.insert is inherited here. Similarly, if you go to the insert query in the tree DB, that one says the same thing. So you can see there's, again, a single choice principle. There's only a single place where we specify the post condition for insert, and basically every other feature in the defer routine section. Okay. So now if you go to database over here, if you go to insert, so that's exactly what you have to do for the post condition. All right. So that's what you gotta watch out for. Okay. So you can see for the contracts, we try to concentrate them on the parent class called database, so that it can be inherited to both of the child classes, single choice principle. On the other hand, for the implementation, you have to do them separately in each of the subclasses, because you either have to implement it using balanced BST, or you have to implement it using an array and also hash table. Okay. Okay. All right. So now where over here, let me just tell you, make a note. Where is exactly here. Okay. Okay, so now let me just point to over here, okay, just to show you. All right, so now number 2 is going to be slightly trickier. Okay, let me talk about number 2.
We cannot see your screen.
Oh, sorry?
We cannot see your iPad screen.
Oh, sorry. The iPad, right? Sorry about that. Let me just explain again. Okay, sorry about that. Let me just undo to where I was. So I think you guys were up to here, right? I think this up to here was okay, right? So now the thing I just described was about the post condition, okay? So now the question was, at the end of the insert, we need to check the post condition for the insert. So the question is, where is the post condition, right? As I just showed you on the code, so the post condition should be exactly over here, right? So now let me highlight it. So now it should be exactly over here, in short. So this is the post condition that will be checked against. So that's a post condition. You can think about the same post condition over here is going to be inherited to the insert in the tree DB, also inherited to the insert in the linear DB. So the same post condition will be in a single place. So that's a single choice principle. Okay. Okay. Any question about point number 1 here? Any question? It will be important for you to understand point number 1 first before you can understand point number 2. So I can pause a little bit to see if anybody got any questions. Okay, so now let me go to point number 2. Point number 2 over here, let me just continue from here. Point number 2, let's say the same DB dot overwrite. And then according to the signature for override, of course, you got to study the behavior in the comment about override. But for now, I just want to illustrate. For override, it's going to be a key and also a value. For example, I might say maybe mark, and then I'll put 46 over here. Let's say that's how I call that, right? So now, guys, so here's my question for you, okay? Number 1, which version of override is called? Which version? You may actually want to start by knowing how many versions of override do we have? How many versions? 1 or 2 or 3? Anybody? How many versions do we have? If you go to database over here, if you look at that, you see here under basic, intermediate, or advanced, right? That's a section I'm talking about. I saw from Jia it said 2, right? I would say 2 is not quite correct. I might know what you're thinking about, but 2 is not the right answer. 1 is actually correct. I tell you why. Okay, let's see this. Under the database class over here, so let's say we got override over here, right? First of all, you can see this particular override is effective. So that should be counted as 1 version for sure. Okay, version number 1. Do we have any additional versions, especially in the subclasses? The answer is no. Let me show you why. If you go to linear DB, for example, right? Remember when we talk about in lab number 0, when we try to create a bad descendant class in order to test the post condition, we say, for example, we inherit from the birthday class, and then we say redefine a particular routine, right? So that means every time, if you want to redefine a version that's inherited from the parent class, you have to say redefine. It's like the override concept in Java. But now, if you look at linear DB, for example, you can see we only say inherit from database, but we didn't say anything about redefine, right? More precisely, if you look at the feature section over here, we do not have any feature that's called override. It's simply not there. You can even verify one more thing. You can see this is linear DB, right? If you simply type override, it is available. However, hit on that, you go back to the override in the database. So that means there's only a single version of override, which is in the database. Let me verify very quickly. If I go to TreeDB, for example, you can see that, again, there's no override here. And then in the TreeDB, if I type override, it's actually going back to this very single version of override that's in the database. Okay, let's agree there's only 1 version of override. And similarly, there's only 1 version of common key DB, interval image, and also inner join. All these basic, intermediate, and advanced, you only got 1 version of the implementation, the lines of code that is in the database, which you have to do. Okay, let me go back to the iPad over here. Okay, so now version of override that's going to be called is going to be, let me use pink over here. Version of override that's going to be called basically is going to be exactly just this version over here, just this one. Okay, only a single version. However, you might be wondering, if there's only a single version that's going to be called, how can we have different behavior between the tree database and also linear database? They should behave differently, right? Because the tree database should behave according to a balanced binary search tree, like a splay tree, which you did in lab number 1. On the other hand, for linear DB, it should really behave according to some array keys and also some hash table values, right? So now, if there's only a single version of the override, how things are going to work out as two different versions. Okay, that's the trick you want to learn from lab number 2. I'm not too sure if you really saw this kind of implementation pattern from your 2030 or 2011. Maybe you haven't, so now it will be the time to learn it. Okay, it's a very common implementation pattern. Okay, we'll run into this particular pattern after the reading week when we talk about a particular design pattern called the template design pattern. But we'll get there. Don't worry. Okay. Okay, so now let me talk about it quickly. Okay, so now override is just one example. That's just one of the basic routines that you have to implement in the database, right? So as I said before, every feature that's in the defer routine section over here, so these are like the basic building blocks, right? Let me just say that again. Think about these are like the basic building blocks. Meaning that in order for you to implement the basic, intermediate, and advanced features, it will be sufficient just by referring to these routines over here. It will be enough, because when you talk about insert, delete, search, has key, and etc., those are basically all the queries or commands you will need in order to update a database, even though the implementation might be different. But at the abstract level, it's enough. Okay. So now, let's say, for example, maybe in the case of the override, part of the line over here, just show for example, you might say insert over here. So now I want you to see this very carefully over here, right? Let me just say that, okay? Let me make it bigger. In the context of override, which is effective, so it's not deferred, right? You are actually referring to a feature which is insert. However, insert itself is actually deferred. You see what I'm doing here? Let me make it a little bit more simplified for you, okay? It's actually very important for you to see this, right? What you're seeing is like this. Let me just simplify. Class A, let's say parents. And then over here, we got some feature over here. Let's say just say F1. F1 is deferred. Okay, and then let's say we've also got F2. F2 is effective. However, F2 somehow refers to F1. Okay, so now this is really what's happening over here, right? So now you can see the F1 over here is really the F1 over here, which is deferred. We're referring to a deferred feature in the context of an effective feature. That's definitely allowed. Okay, and then I want to go a little bit further for this simple illustration over here, and I'll go back to that particular example. Okay, this is one, and then let me make it a little bit smaller over here, and then let me add some subclasses quickly. Okay, so now let's say we got one subclass over here. Let's say class child number 1. Let me got another class over here. Let's call that class child number 2, right? In the case of class child number 1, that one inherits from parents. And since I don't want to make this class deferred, so that means I must implement F1, right? So F1 must be implemented somehow. Must be. Right? You can see that's effective over here, right? So this is child number 1. Let's take a look at child number 2. That one there also inherits from the parents. Okay, let me just, sorry. That one also inherits from the parents. And that one there, let's say also F1, because you also have to implement this particular one. And then, so this will be do and also end, right? So now, think about this. Okay, apparently these two classes are simply just subclasses. So you would draw the inheritance relation arrow over here like that, right? Like that. Okay, so now at the runtime, let's say if I simply declare, let's say maybe some objects of type parents. And now let's say somewhere I initialize the object to be some binding, which can be either child1 or child2, right? Either one. So now if I say objects dot, let's say F2. So now when I call object.f2, how many versions of F2 do I have? Only one version, which is over here. However, it boils down into two different ways of executing the body of implementation for F2 dynamically, because depending on what the dynamic type is, if the dynamic type of object happens to be child number 1, so that means this F1 over here is going to call this particular version. On the other hand, if the dynamic type of this particular object at this point happens to be child number 2, in that case, this means F1 is actually going to call this particular version, right? It really depends, even though there's only a single definition for F2. However, the version that's going to be called on F1 could be either this or this, depending on what the dynamic type is for object, right? It's a simplified scenario over here, okay? Let me just go back there and finish the story for database, okay? So now if I go back to the database over here, so now you can see there's only one, you can see everything is analogous, right? That's why I try to give you the simplified scenario first. So now in order for me to execute db.override over here, I'm basically somehow along the way, I'm gonna execute maybe insert over here. But now, which version of insert am I executing over here? So that's your question. Guys, in this particular setup, right? So now this in turn will execute, let's say insert, but which version? Which version of the insert are we really executing? You can see the current over here, right? Current is like a this in Java, right? As we said. So the current here is really like a DB. So it's effectively that we are saying db.insert. But now, which insert are we executing? We said before there are two versions of the insert. Which version? Is it going to be, yeah?
Is it 2?
Oh, sorry, say it again.
Is it 2?
Is it 2? Why would you think that's 2?
Because DB is like part of linear DB, which is the version 2.
Yeah.
So when we call insert, it should be that one.
That's exactly right. Thank you. That's exactly right. So you can see over here, DB at this point, because remember we instantiated to be of dynamic type linear DB. So that's why when we're executing insert, that one there will be the insert over here, version 2. Yes, that's exactly right. Okay, very good. All right, guys. So that's it's very important for you to really see this overall picture over here between the three classes, right? We try to really give you the best design possible so that you only define. Let me recap, and then I'll take your question. Okay, you can think about in terms of the contracts. We put most of the contract at the level of the parent class database over here. So there's only a single place where we specify the contracts. Not only that, we are also trying to use the model only to actually write a contract, pretty much like what you learned from lecture 4 and lecture 3. Okay, and number 2, for all the basic building block feature, they are simply just deferred, which means you will have to implement them accordingly, either here or here, using either balanced BST or using keys and values. So now the most important part is when you think about how the basic, intermediate, and advanced, how these features should be executed at the runtime. There's only one version for each one of them, only one version, because they are not redefined in the child classes. However, in their body of implementation, they are going to call the basic building blocks, which themselves actually got two different versions. So now, really depending on what DB is over here, right? So you're going to call different versions. One final remark. So far, we talked about the DB over here of dynamic type linear DB, right? So what if I simply want to change the behavior? I can do the following. I'll say number 3 over here, right? What I can do is I can reassign DB into a different dynamic type. So I can simply say creates over here. So now I can put a different dynamic type. Rather than linear DB, I can put tree DB. And then I can say db dot make. So now I'm changing that into a different dynamic type, which is tree db. So now if I try to call exactly the same lines as before, if I say db.insert, and also I try db.override. So now I'll write it down, and then I will mention that, and then, so let's say number 4 and number 5, right? Now if I say db.insert, and whatever, and also I say db.overrides, also something over here, right? So now you will know for this particular insert over here is actually going to call version number 1, right? Because now the dynamic type is actually tree db. And then for the override over here, it is still going to call this particular version, correct? There's only one single version. However, when we get to this point for the insert, it's going to in turn call db.insert. In which case, it's still going to call version number 1 over here. Okay, so hopefully it's clear to you, right? It's quite a bit of stuff to really realize over here, but once you get the essence about this visualization, you pretty much get the architecture for lab number 2. Of course, there are more features over here. I'm just showing the representative set. Okay. Guys, any question about the illustration over here on this page? Any questions before I move on to the rest? Any question, please?
Hello, Professor.
Go ahead, please.
Is it possible that I have a post condition in the subclass?
Yes. Yes. In this particular lab, you know what? In this particular lab, no. I think for this particular lab, you put all the contracts in the parent class. But I would say in practice, when you have an inheritance relationship, it is possible you may have some post condition in the parent class. You have some additional post condition in the child class. It's possible. Yes.
Okay.
But for this lab, it's not the case.
Okay.
Yeah. Good question. Yeah. I think as I try to explain to you, for this particular lab, we try to maintain single choice principle as much as possible, so that we don't want to say, for example, if you got this particular contract for entry added, so that one is going to be specified in terms of the model, which is, oh, by the way, the model itself, we can see here, is also deferred, meaning that when you check this particular post condition at the runtime, which version of the model is going to be called? Well, depending on what DB's dynamic type is. If the dynamic type is simply tree DB, you're going to call this version of the model. If the dynamic type of model is if the dynamic type of DB is actually linear DB, in that case, you will be calling the model over here, right? Again, it depends, right? But it's a single place where we specify the contracts. Okay. Okay, any questions about this architecture here? I just got a little bit more on my agenda, and then I'll start answering your question. A visual of model, yes, Parthiv, I'll definitely go there. Yeah, bear with me just 1 more minute or 2. Okay, so let me now go back to the instruction. Okay, I promise I'll definitely give you visualization for the model. Give me just 1 moment. Okay, what we have just said is really about the written part in the instruction. So you please still read it, even though you get the idea I illustrated to you. It's very important, right? Okay, so for section number 7, it's just about how you can get started. Okay, about downloading the starter code and etc. Right? So for that part, I'll leave to you. Okay. And then what if you get stuck? I would say maybe refer to the optional tutorial if you feel the need, or you can refer to the problem section and also starter tests. I know many of you already started to really try to learn how to read this unit test that we gave to you as a documentation. But if you haven't learned about how to do it, you can either visit me, my office hour, or maybe talk to the TA. They will help you on reading the test cases. It's quite important. Okay. All right. Okay, let me see anything else about the grading scheme. Pretty much like the last time, right? I would say we already gave you about 50% of all the starter, meaning that if you can get your submission compiled and also pass all the starter tests, you can get already up to 50% already. And then the other 50% will just be some additional boundary cases or tests on the contracts. That's what we will do. Okay, it's pretty clear, I think. Section number 9 is about the design diagram you have to draw. Okay, I would say based on what we have done so far, I think this particular this illustration over here, it already gives you some idea about how the classes interact with each other. So I think you don't necessarily have to wait until next, maybe Thursday or Friday, to actually draw the diagram. You can maybe start some sketch already. Feel free to visit my office hour to show me your sketch. I'm more than happy to give you comments, okay? Okay, so when you draw the diagram, please make sure you definitely want to read section 9.1. So this one talk about what routines and also what classes you want to include, okay? And then there will be some requirements about drawing the diagram. So they're all in the instruction, right? Number one is about the page limit. Eventually, you want to export your diagram as a PDF into a single page, okay? And number two, about the syntax for the diagram, you can simply click on this link. So that one brings you to the lecture slides, right? So this is basically the first part of your week number 4 lecture, okay? And then the tool you're going to use will be draw.io, right? If you refer to Tuesday's Q&A, I did a very quick demo about how to use the draw.io. Again, you can refer to it, right? The most important thing is you will have to import this particular library, XML. How do you find the library? The way to find it would be, let me show you here. If you go to, give me one moment. If you go to your starter projects over there, for your, okay, let's say this. In your starter projects called database, right? If you go in there, so there is a folder called docs. So this is a library you have to import to the draw.io. Okay, just it's not really on the E-class separately. It's actually in the starter projects. Okay. Okay, so that's just the instruction about how you can create a diagram, you know, from scratch. Okay, you can take a look. Okay, and then the submission as usual. I will open up the submission hopefully over the weekend. So by Monday, for sure, you can start submitting your partial project just for backup or just to check some basic checks. Okay. All right, so guys, as I promised, I'm going to talk about visualization of model. Let me do that, and then you can still ask your question, right? We can go all the way to 5:30 if necessary, okay? Let me go back to my iPad. Over here, let me just minimize the web browser, okay? I think, visually speaking, this is a very interesting lab you want to think about, right? So let's say this. Runtime. Think about okay. Let me talk about different layers over here. First of all, we divide between implementation and also specification, right? Let's say what's really above is the specification. So this is the math model. And in this case, it's going to be a relation, right? I'm going to assume you're going to study basically the lecture series number 4, where I talk about some basic relational operations. So that's something you have to get prepared in order to also do quiz number 4, okay? So I'm going to talk about some simple ones in just a moment, right? And then, so at the lower level there, this is going to be implementation. And now for lab number 2, there are 2 possible implementations that we are considering, right? So one is the tree DB, the other one is the linear DB. So let me separate them over here, right? So now number 1, I'm going to say the tree DB. And also we got linear DB. Yeah, since you only asked me to visualize, so I'm just give you an example, right? Linear DB, right? Okay. Let's say for the tree DB, it's going to be a binary search tree. Basically, you can think about under the hood, we actually got BST, which is really pointing to some binary search tree. For example, let's say we got, let's say from string into integer, right? Let's say. Let me say it's going to be A. Let me say, how about this? D, 23. So the string value is the key, right? So it's going to be sorted alphabetically, right? And then over here, you learn very well, it's about tree nodes. So this will be the left, this will be the right, right? Let me just draw a few more. And then, so this one will be, let's say C, and then 14, okay? Just arbitrary. And this one over here is going to be, let's say F, and then it's going to be, let's say 64. Okay, let's say we got 3 nodes. And of course, these will just be external, right? External nodes over here. So that's the BST we're talking about, right? And on the other hand, depending on what the dynamic type is, dynamically, it could be a tree DB, in which case you get a splay tree. What about linear DB? So this will be corresponding to the visualization I showed to you. Let me show you again quickly, right? I'm going to draw it as well. If you refer back to the instruction over here, so this will be the visualization you should see. Let me take a look. Over here. Okay, over here, page number 4, about the keys and values, right? Let me draw that, okay? So now for the same database over here, it could be represented in a different way, linearly. So now we got keys over here. It's going to be an array of size 3, of course, right? It's going to be C, D, and F. Although I don't want to give you the impression that the keys should always be sorted array. It's not necessarily the case. Not really, okay? So let me just put it here. Let's say D, and also F, and also C. Okay, it doesn't have to be sorted. Let me emphasize that, right? Index 1, 2, and 3. And also the values is going to be a hash table, right? For the hash table, the best way to visualize it is like a table over here, right? And then over here, you got key, you got value. You got key, and so you got value, right? So here we actually got 3 entries over here. So now, for example, you can see, for example, D could be here, and C could be here, and F could be here, right? The order of the keys in the hash table is not relevant. Okay, normally we don't worry about the order in the hash table, depending on how you insert them. So C will be corresponding to 14. And also D will be corresponding to 23. F will be corresponding to 64. So now, guys, the first thing you want to get through your mind, even though we are talking about BST versus keys and values, right? We are basically talking about 2 very, very distinct implementation strategies. However, they are really representing the same database. Can we agree on that? I hope yes, right? All right.
Yes.
Good, very good. Thank you. Very good. So now, let's say this. Actually, that's a very important learning outcome for this course. Remember, we talked about design. What you learned back in 2030 and 2011 is really about what are the possible ways you can implement, for example, either using a tree or using a hash table. So these are the different strategies. However, you want to promote your thinking a little bit higher to say, is it possible that these 2 implementation strategies are simply just hidden from the clients, and the supplier may want to present just a public abstract view to the potential clients, so they can understand, not really in terms of the tree or in terms of the database level, in terms of the hash table. They can implement differently. Let me show you. So now, mathematically speaking, it can be much simpler. So we don't have to worry about anything about rotation, anything about splay operation, nothing about linear probing, nothing about clustering, right? So those are the buzzwords you learned back in 2011. I'm gonna leave you to that, right? So now, as far as the model or specification view is concerned, there's only one view, which is about mathematical relation. And what is really a mathematical relation? It's simply a set of pairs. So what I will do is very simple. It's going to be just a relation. Oh, you know what? I'll give you 2 possible views, right? Either I believe this is how you guys did it back in 1090, right? Just mathematical relation. In which case you got domain, right? Also you got value, domain and range. In this case, we got basically we got D, we got C, and we got F, right? Again, domain is a set, so the order doesn't really matter. And also we got maybe 14, we got 23, we got 64, right? And now, what is the relationship between them? So D is mapped to 23, like that. And also C is mapped to 14. C is mapped to 14 over here. And also F is mapped to 64. All right, so you can see amazingly, from the abstract point of view, you only have to understand the database as a relation over here, exactly how you will understand it abstractly back in 1090. However, we are linking to what you learned back in 2030 and 2011, you can also implement using different strategies. Either, for example, using a split tree, or you can use a hash table and array, right? So now the question is, how do we write contract? Number one, how do we write contracts? Number one, for the contracts. Contract is all going to be specified in terms of this particular relation, all of them, okay? All in terms of the relation, for sure. Oh, actually, I promise I'm going to show you another way to visualize a relation. If you're not so comfortable with these two, this way of visualizing relation, this is another way. You can think about another way is to draw a set. And then you will simply say maybe D is related to 23. And also C is related to 14. And also F is related to 64. Okay, guys, this is just another way. So which way you prefer is completely okay. Okay. All right. It shows that my internet might be a little bit unstable. Okay, but don't worry, recording is still going on. Okay. All right. So let me now go a little bit further here. So now you can see every time you write contracts for the database, you have to write in terms of this relation here or this view over here, either way, right? You always do that. You don't really write any contracts in terms of the split tree or in terms of the hash table and array. You don't do that, right? That's for the purpose of information hiding and single choice principle, as we talk about in the lecture series number 3. So now, how do you actually implement the model query? That's the question, right? If you refer back to here, in order to implement the model, you can see for the model is simply just deferred at the level of database, meaning that in order to convert from the underlying implementation to the model relation, you have to go down to the subclasses. Okay? For example, if I want to know how to convert from the binary search tree into the model, I need to look at the model over here, right? On the other hand, if I want to see how to implement the model relation using the keys and values hash table, I need to go to this particular implementation, right? So there are 2 implementations we need to implement. Let me go back here. So you can think about, in order to, there are 2 things we want to see. Let me say this, okay. So now for the tree DB over here, so now we want to know, number 1, how to convert from this particular BST over here, convert that into this particular relation. So this is the model. So this is the model relation. Model from tree DB. That's the conversion you have to do. Number 2, how do I actually, in terms of these 2 attributes over here, so you have to also convert them into this particular relation, right? So that one will be the model from linear DB. Okay, linear DB. That's what we're going to do. Okay, so now we talk about several things. This will be the implementation of the model. This will be the implementation for the model. This will be the implementation for the model. And then once we get a model, you can actually specify all the contract in the database routine using just the model, right? In terms of the relation over here. All right, so Parthiv, do you think that that's enough for visualization? Maybe that's what you needed?
Yeah, just a simple question.
Okay, let me take a look. Yeah, give me one moment. Let me read it. We represent an array or sequence. Can we represent a set of relation by? Okay, let me read it more carefully. We represent an array or sequence by. Can we represent a set or relation by that? So are you saying programmatically or just conceptually?
Yes, programmatically.
Programmatically.
So, like,
how do you create a relation? Is that what you're saying?
Yeah.
Okay.
How can we create
Sure.
one relation?
I'll refer you to this. Okay, but I hope this visualization is helps, right, over here.
Yeah, yes.
All right.
Visual is correct. Yeah, I got it now.
Okay, no problem. Let me now go to where you should really look at. Let me just go bring out the slides. So if you go to, let me just tell you where you should go. Go to the lectures page. And then, okay, 3311, and go under week number 4. Not too sure if you got to that part yet, but if you go to 4B over here, right? If you go to 4B, and then I want you to go under math models example test. So this is slide 18, okay? So this one shows to you how you can create a relation over here. Okay, this is what you need.
Okay.
Okay, so
Yeah.
the one I show over here is about how you can create a relation from a tuple array. That's one way to go. Another way to go would be, so I would suggest, so of course, what we cannot really we cannot exhaustively enumerate all the features you need for the relation. What you would do instead is go to the relation class over here in the Eiffel Studio. If you go there, you can see there are many things you can use, right? So these are all the commands and query that you can call. One of them that might be useful, I believe, is called extend. Okay, if you go there, the extend is something you can use, right? So you can create an empty relation and then keep extending it with more pairs, for example. All right?
Okay, yeah, thank you.
No problem. Okay, guys, any more questions? I finished all the things I would like to discuss with you, and then I believe I also answered all the questions on the chat. So I don't mind answer more if you got any more questions. Okay, I'll just stop this page here. Any more questions? Yeah, I know this may not be a very good time. I know you may have classes, you may have other things, but you know, it's recorded, so I just want to say what you need to know. Hopefully you can also catch up with the recording, right? Any questions? So everybody's okay? All right, should I call it a day? Oh, sorry, anybody want to ask a question? Go ahead.
No, you're fine, I guess.
You think you're fine, okay? Yeah. All right, so yeah, everybody, thank you for coming. But I would say lab number 2 has been released since Monday. So I would suggest if you haven't started, we're giving you the Q&A actually one day earlier than the Q&A for lab 1. So we're hoping that just help you get started and to understand what's really the learning objective we would like to achieve for this lab. All right, off you go, do the work, and then for this week, we still got a scheduled lab session tomorrow. And for next week, we still got a regular session Wednesday, Thursday, and Friday. Also, I got my office hour. You can still drop by to ask questions. All right? All right, so thanks for coming, and then I'll see you next time. Okay, have a good day.
Just a last quick question, Professor.
Sure, go ahead.
In the PDF, it says in 4.7, in 7.1. In 7.1, the step number 4.7.
Yeah. One moment. 7.1, you said?
Yeah, 7.1, 4.7.
Okay. Yeah, what about it?
It says implement tree it and linear it. So are they in the iterable?
They are the iterator pattern, yes. For the
Yeah.
iterator pattern, you will have to study lecture series number 4 in order to do that.
Yeah, sure. Yeah. Okay, just making the confirm that it is some different, I mean, the different class and not
Yeah, exactly. Yeah,
DDD.
absolutely. Yeah. So you're basically given all the classes for this lab. So you just have to somehow, fill in the blanks. Yeah.
Okay, thank you.
All right, sounds good. All right, guys, if no question here, should I let you go? I guess so, right? All right, have a good day. I'll speak to you later. Bye-bye.
Bye.
Bye-bye. Bye-bye.